A quick revision on complex numbers, important points. Properties of conjugate, modulus and argument. Conjugate. Modulus of z is modulus of z bar. Z bar is the mirror image of z in real axis. That is, when we consider the conjugate plane, if we consider this as A, z1, B, this is z bar, that is the mirror image. This is the real axis and this is the imaginary axis. Z plus z bar is 2 into real part of z. Z minus z bar is 2 into imaginary part of z. Z bar is modulus of z square. Z1 plus Z2 and so on Zn whole bar is Z1 bar plus Z2 bar plus so on Zn bar. Z1 minus Z2 whole bar is Z1 bar minus Z2 bar. Z1 Z2 whole bar is Z1 bar into Z2 bar. Z1 by Z2 bar is Z1 bar by Z2 bar when Z2 is not equal to 0. Z1 bar whole power n is Z1 bar whole power n. Z1 bar whole bar gives rise to Z. If alpha is f of z, then alpha bar is f of z bar, where alpha is f of z is a function in complex variable with real coefficients. Now argument. Argument of z1, z2 is argument of z1 plus argument of z2. Argument of z1 by z2 is argument of z1 minus argument of z2. Argument of z whole power n is n argument of z, where n belongs to integers. Argument of z is 0 or pi when z is purely real, that is z is z bar. If argument of z is pi by 2 or minus pi by 2, then z is purely imaginary, that is z is minus z bar. Here you can consider this, that the function of argument function behaves as a log function. Modulus. Modulus of z is 0 when z is 0. Minus of modulus of z is less than or equal to real part of z less than or equal to modulus of z. Minus modulus of z is less than or equal to imaginary part of z is less than or equal to modulus of z. Modulus of z is less than or equal to modulus of real part of z plus imaginary part of z. It is less than or equal to root 2 into modulus of z. Modulus of z whole square is z into z bar. Modulus of z1, z2 and so on Zn is z1 modulus into z2 modulus into z3 modulus and so on Zn modulus. Modulus of z power n is modulus of z whole power n when n belongs to integers. Modulus of z1 by z2 is modulus of z1 by modulus of z2. Modulus of z1 plus z2 plus z3 and so on Zn is less than or equal to modulus of z1 plus modulus of z2 and so on modulus of Zn. Z1 minus z2, modulus of z1 minus z2 is greater than or equal to modulus of z1 minus modulus of z2. Modulus of z1 plus z2 whole square is equal to z1 plus z2 into z1 bar plus z2 bar. Now let us see De Moivre's theorem. If n is any integer, then cos theta plus I sin theta whole power n is cos n theta plus sin n theta. If n is a rational number, then one of the values of cos theta plus I sin theta whole power n is cos n theta plus sin n theta. If n is of the form p by q, where p and q belong to integers and q is greater than 0, p, q have no common factor, then cos theta plus I sin theta whole power n has q distinct values, one of which is cos n theta and sin n theta. For example, if z is r into cos theta plus I sin n theta, where n is a positive integer, then z power 1 by n is equal to r power 1 by n into cos 2k pi plus theta by n plus I sin 2k pi plus theta by n, where k is equal to 0, 1, 2 and so on n minus 1. Now, the nth roots of unity. Let x be the nth root of unity, then x power n is 1. that is cos 2k pi plus I sin 2k pi, where k belongs to integers. this is just the another form of this. Now, then nth roots of unity are alpha power t, where t is 0, 1, 2 and so on n minus 1. That is, nth roots of unity are 1 alpha, alpha square, alpha power n minus 1. The sum of roots can be given as 1 plus alpha square plus so on, alpha power n minus 1 is 1 minus alpha power n by 1 minus alpha, that is 0. This can also be stated in this form. Product of roots. The product of all these roots is minus 1 power n to minus 1. Minus 1 power n plus 1. You have to note an important point here. The points represented by the nth roots of unity are located at the vertices of a regular polygon of n sides inscribed in a unit circle having center at 0, 0, one vertex being on positive real axis. That is, can be represented like this. This is first one, second, third and so on an. This angle, as you know, it is 2 pi by n. Now, cube roots of unity. For n is equal to 3, we get the cube roots of unity. They are 1 cos 2 pi by 3 plus I sin 2 pi by 3, cos 4 pi by 3 plus I sin 4 pi by 3. That is 1 minus 1 plus root 3i by 2 minus 1 minus root 3i by 2. These are generally represented as 1 omega square. They are the vertices of an equilateral triangle whose circumcenter is 0, 0 and circumradius is unity, that is 1. This is represented on the plane as an equilateral triangle. This is omega square and 1. The concept of rotation. If Z, Z1, Z2, Z3 are three vertices of a triangle, then described anti-clockwise, then Z2 minus Z1 by Z2 minus Z1, that is OQ by OP into cos alpha plus I sin alpha, that is equal to CA by CB. I'll draw the diagram here. When you consider the plane, a triangular plane. This is PQ, as we wrote here. P is Z2 minus Z1 and Q is Z3 minus Z1. And we consider here another plane, that is ABC. When we rotate this plane in the clockwise direction, anti-clockwise direction of alpha, then this also should be rotated in the anti-clockwise direction alpha, where A is Z1 and B is Z2, C is Z3. Note, argument of Z3 minus Z1 minus argument of Z2 minus Z1 is alpha. That is the angle through which OP becomes parallel to OQ. Geometrical applications. As you know, section formula Z1, Z2 can be two complex numbers representing A and B. Then CZ is the point dividing internally in the ratio m is to n. Then AC by BC is m by n. So C divides in the ratio nz1 plus mz2 by m plus n. Similarly, for external division, it is Z, that is C dividing Z, that we have considered here Z. That is nz1 minus nz2 by n minus m. And if CZ is a midpoint, then it is z1 plus z2 by 2. Condition for collinearity. If three real numbers L, M, N such that LZ1 plus MZ2 plus NZ3 is 0 and L plus M plus N are 0, then Z1, Z2, Z3 will be collinear. Now let us come to the equations of lines. Equation of a straight line. rotation formula. Let A z1 and z2, that is A z1 and B z2, be any 2 points lying on a line. We have to obtain the equation of this line. For this purpose, let us take any point CZ on this line. Since argument of z minus z1 by z2 minus z1 is 0 or pi, then z minus z1 by z2 minus z1 is z bar minus z1 by z2 minus z2 bar minus z1. Let us consider this as the equation 1. And the general equation of line is given by, from the equation 1 we get as z a bar plus z bar a plus b is 0, where a is I into z1, a bar is I into z1 bar minus z2 bar, ib is z1 bar z2 minus z1 z2 bar, where b belongs to real numbers. Next we come to slope of a line. From this equation, slope is given by real part of a by imaginary part of a. The equation of line parallel to this line is z a bar plus z bar a plus lambda is equal to 0. Equation of line perpendicular to this line is z a bar minus z bar a plus I lambda is 0. Equation of perpendicular bisector. Consider a line segment joining the points AB, where A is z1 and B is z2. Let L be its perpendicular bisector. And PZ be any point on L. Then we have already been given that PA is equal to PB. Then Z minus Z1 modulus is equal to Z minus Z2 modulus. That is Z into Z2 bar minus Z1. The perpendicular bisector equation can be written as Z into Z2 bar minus Z1 plus Z bar into Z2 minus Z1 plus Z1 Z2 bar minus Z2 Z2 bar is equal to 0. Now, distance of a point from a line. Let us assume that the given line be ZA bar plus Z bar A plus B is 0, and the point from which it has to be measured is ZC. The distance is written as ZC A bar plus ZC bar A plus B whole modulus by 2 into modulus of A. Coming to equation of circle. Equation of circle of radius r and having center is represented by modulus of z minus z0 is r. It can also be represented, this is actually the general equation of a circle. It can also be represented as z bar plus a into z bar plus a bar z plus b is 0, which has a center at minus a and radius is root over a bar minus b. This is a circle only when a bar minus b is greater than 0. The equation of circle described on line segment AB, where AB are taken as the diameter, is given as, let us consider a circle. Sorry, I think it did not come as a circle. Let AB be the diameter. Then this is Z1, Z2, Z. The equation of it can be given as Z minus Z1 into Z bar minus Z2 bar plus Z minus Z2 into Z1 bar minus Z1 is equal to 0. A few geometrical applications. Let ABCD be a cyclic quadrilateral. Let A be Z1, B be Z2, C be Z3 and D be Z4. Then it is represented as a quadrilateral. Then Z4 minus Z1 by Z2 minus Z1, Z2 minus Z3 by Z4 minus Z3 is purely real. The equation of tangent can be given as, let modulus of Z be R. Then the equation of tangent is Z1 bar plus Z1, Z bar Z1 is 2 into modulus of Z1 bar whole square, that is 2R square. Or it can also be given as 2Z by Z1, Z by Z1 plus Z bar by Z1 bar is 2. Or real part of Z by Z1 bar is 1. If Z modulus of Z minus Z1 by Z minus Z2 is lambda, where lambda belongs to real numbers, and it is not equal to 1, then z lies on a circle. Some important points to remember. z1, z2, z3 form an equilateral triangle if 1 by z2 minus z3, 1 by z3 minus z1, 1 by z1 minus z2 is 0. That is, if z1 square plus z2 square plus z3 square is equal to z1 z2 plus z2 z3 plus z3 z4. Modulus of z minus z1 plus z minus z2 is lambda. It represents an ellipse. When z1 modulus of z1 minus z2 is less than lambda, where z1 z2 are the foci. If z1 modulus of z1 minus z2 is lambda, then the line segment contains these two connecting z1 and z2. And z minus z1, modulus of z minus z1 minus z minus z2 is lambda. This represents an hyperbola. If z1 modulus of z1 minus z2 is greater than lambda, z1, z2 are the foci, then modulus of z1 minus z2 is lambda. It represents a line segment excluding the points z1 and z2. Thank you for watching.